start tonight off with a question. How many of you have ever baked an apple pie from scratch before? And when I say scratch, I mean even the crust, because we all know how easy it is to grab an apple pie crust that's pre-made and to piece it all together. Now, if you have, then I'm sure you would agree with me that it takes time to gather all the ingredients and put them all together. And you also need to have knowledge of how those ingredients interact with one another, whether it's salted versus non-salted butter or baking powder versus baking soda. And when you look at them, they all seem like just simple ingredients. But the reality is there's often an entire behind-the-scenes world that goes on, just like an apple pie baking does. And so what I want to do tonight is have us take a closer look and see if we can dig deeper. So let's take the main ingredient of the recipe. We'll take the apple, especially since we are in Washington, and we produce 70% of the nation's apples, based on the USDA National Agricultural Statistical Service. So what's the first thing I notice? Number one, it's a Granny Smith apple. We could choose any variety, but why this one? That's because of the genetic makeup. This happens to be a really good baking apple. So now let's take a closer look. The first thing I notice now is the core and the seeds within that core. And they're there because an apple is really an upside down flower. So what happens is in the springtime, the apple trees will blossom and the flowers will open, they get pollinated, and the petals will fall off. But the flower parts of the apple are still there. And so they grow and then the cells expand, and that's how apples grow. The other interesting thing about these seeds is that if I were to take each one and plant them, every single one of them would give me a completely different apple variety. And that is partially due to the fact that apples are very heterozygous, which means that there's a lot of different gene pair combinations that can occur. Okay, now that might raise another question. Then how do you plant an entire orchard of Granny Smith apples if every seed gives you a different variety? The answer is through grafting. There's two different parts to an apple tree, the scion, and that is the variety that you actually want to harvest. So in this case, it might be a Granny Smith. The other part is the rootstock. That controls how big or how small that tree grows. So we take a sliver of budwood, which is from the scion, and put that into the rootstock. And those tissues, they grow together as one. There's entire groups of nurserymen that create thousands and millions of baby apple trees for farmers when they're ready to plant new orchards. Now, that leads us to another point of rootstocks. Rootstocks themselves have changed a lot over the last 30 years or so. It used to be this giant 24-inch trunk that would create this huge 3D canopy such as the one up here. And over time, through breeding, we've developed rootstocks that give a much smaller trunk. So we call those dwarfing rootstocks, where they're only 2 to 6 inches in diameter. Now because of that though, the root footprint itself is much smaller. So now that we have this baby Granny Smith apple tree, it actually needs support because it can't physically handle the amount of fruit that it can bear. And it also needs help supporting through the wind and sometimes the snow loads as well. Now all this might seem kind of silly because now we have a problem that never existed when we had 3D canopies, but this actually can be really advantageous for light interception. You see, trellis systems, whether it's a fruiting wall or a V trellis, which is basically two little fruiting walls together, can maximize light interception, which is important for to maximize the production of each leaf. Okay, now that brings up another question. What do leaves actually produce in the first place? Right? Well, when we were in grade school, we probably learned about the 3 ingredients, and there's that special word again, of what it takes to make plants grow. You need light, you need soil, and you need water. Right now we're talking about the light portion. So leaves absorb light, and From that, they photosynthesize, which creates carbohydrates, which is a source of energy. So in these 3D canopies, a lot of the leaves, they're shaded, which means they use more energy than they can produce, and that's not good. But in a trellis system, every leaf on the tree can then contribute to the energy supply. There's two places then that those carbohydrates will end up after photosynthesis. So one place is in the woody tissue, whether it's the bark, the trunk, and the branches and leaves, or it will end up in the fruit. And this is where crop load becomes really important. So crop load basically means the number of apples on a tree. If you have too many apples on a tree, so high crop load, then you're going to have competition between the fruit. And the fruit will be small and it won't color very well. But if you have a low crop load, not a lot of apples on the tree, then the tree will actually produce a lot of new baby shoots, which take up a lot of energy and nutrients away from those apples. So now, let's review where we've come so far. We started with an apple pie, then we zoomed into the apple itself, and we learned about 3 different ingredients that it takes to make a plant. Okay, but now we're going to take a closer look into soil. Ingredients that contribute to a particular soil is called parent material. In Washington, our parent material stems from the Cascade Mountains and the basalt layers that come from the lava flows. And even more recent activities, such as in 1980 when we had the Mount St. Helens eruption, that contributed to our soils. A lot of orchards are planted on alluvial fans. If you drive up Highway 12 and you head to Natchez, you'll see these beautiful, gorgeous foothills with these claw marks all the way down. Those are great examples of alluvial fans. So wind and a lot of water erosion will push these soil particles down to the valley floor, create a very fertile environment. On the east side of the Cascade Mountains, where we grow most of our tree fruit, we have soil that's really sandy and silty. Those are the characteristics, which create a soil that's very, has a lot of drainage, which is a good thing. And that's because if it doesn't drain well, then you're going to have waterlogged soils. And basically, you're drowning the plant. You don't want that. So because the soil type itself, we can control the amount of water we give to the trees much better, which then brings us to our next ingredient, water. Our climate in general in Washington is very arid. It's very dry, which is a good thing in a lot of ways because it reduces pest pressure and disease pressure. But interestingly enough, if it wasn't for irrigation systems, growing tree fruit wouldn't even be possible. To give you an idea, rainfall in Yakima is about 8 inches per year. Now for an orchard, we need 42 inches per year. The good thing though is that growers are already employing ways to conserve water, whether it's changing to drip irrigation instead of sprinklers, or converting to shade net instead of using overhead sprinklers again to reduce sunburn, and just reducing overall excess water use. The other new recent thing in irrigation systems is the ability to apply fertilizer at the same time. And this is called fertigation. Okay. And so this can help us reduce the amount of fertilizer we use in general because it delivers the nutrients straight to the tree itself and allows for faster uptake by the tree. Okay, so let's say we've gone through the entire season, we've made it through bloom, so the trees have blossomed, we've watched the fruit grow well, and now it's fall. Now what? How do we know when the pie is ready to be taken out of the oven? We have a timer for that, right? Well, we don't have timers in the orchard. It'd be really nice, but that's not the way it works. We can tell an apple is ready to harvest based on how much starch has converted to sugar. You should see behind me a starch scale. And so when an apple is cut in half and we spray an iodine solution on it, the starch will turn to this grayish black color, while the sugar won't. So the more sugar that an apple has, the more ripe it is. Okay? And this also helps us decide whether or not we should ship it or store it. If an apple is ripe, we don't want to store it very long. We need to get it to the consumer. Otherwise, they'll experience an overripe, mealy apple. But if it's less ripe, we can store it in a controlled atmosphere, also known as CA. Okay? So this is a way we can manipulate the oxygen level and the carbon dioxide level in a refrigerated room to slow down respiration. If we can slow down respiration, we can slow down fruit ripening. In general, when fruit is stressed, it respires faster. And the actual harvest of an apple is a stress event. You're detaching it from the mother plant, right? And so our job is to slow down that respiration and kind of put the apples to sleep for 3 to 6, 9, sometimes even 12 months. And then when grocery stores have a high demand for apples, because everyone's making a beautiful apple pie for Christmas, we can open up the CA rooms, and then the apples we begin to start waking up and ripening. That way, when you go to the grocery store, you can purchase a properly ripened piece of fruit. And that is the ultimate goal of any grower or packer. So we looked at one ingredient in a lot of detail tonight, which was really neat. But if we take a step back and look at the big picture, each one of these other ingredients has a recipe all unique of their own to be explored. And we could do this investigation on any other kind of pie too, whether it's a key lime pie, a pecan pie, chicken pot pie, right? There's a science to every one of life's simple treasures. And that's what's so exciting about being part of agriculture, is it's an accumulation of all the different sciences together, whether it's biology, physics, engineering, and meteorology, computer sciences, also geology, and chemistry, and sociology, and astronomy. Even things like marine biology, as we learn about how our production practices impact other ecosystems. And that's why I love being a horticultural researcher, because I get to study all these relationships and interconnectivity of these pieces that can create something nutritious and enjoyable for my community and my world. So thank you, and bon appetit.